What's going on here? Why are they all staring at a capybara? What do you think they are seeing? Why not find out for yourself? I've got a simple experiment for you. As soon as the music starts, stare at the center of the image on screen just like they did. Don't move your eyes or your head. Did you see that? A purple Pikachu shadow. Why is your brain making you see things that aren't really on the white background? So here's the cool part. There's an explanation behind this fascinating illusion. When I was younger, I noticed this strange phenomenon but never thought to Google it. I figured it was just because my eyes were tired. But during this course, I got more curious about how vision works. And that's when I thought, why not dig deeper? So I decided to explore more about this phenomenon through a simple experiment. I wanted to know how long these shadows linger in our vision after staring at an image, and how are their colors linked to what was originally flashed on screen. For the experiment, I got people to do exactly what you did earlier. Stare at an image, then at a white background. I tested 2 images, each with a different color, and also varied how long they stared at each image. Then I timed how long the shadow lingered in their vision, and also noted the colors they saw. So here's what I found. Many participants reported that staring at the orange capybara created a blue shadow, and the yellow capybara left a purple one. And staring at the image for 15 seconds instead of 5 also made the shadow last longer. The shadow also became more vivid and intense in color. For example, after 5 seconds of staring, some saw more of a grayish purple shadow, but after 15 seconds, everyone saw a clear purple shadow. Okay, so what exactly is this shadow I keep talking about? Well, it has a real name. It's called a negative after image. Basically, when your eyes trick you into seeing colors that aren't really there. Your eyes have tiny sensors called cones that detect color. There are 3 types: red, green, blue. So let's say, for example, you stare at a yellow image for a while. Both your red and green cones will be working hard to send signals to your brain, but eventually they get too tired. So when you look at a white background, in theory, only the blue cones are left working, so your brain sees a blue after image. However, in reality, this might not always be the case. In our results, staring at yellow often produces purple after images instead of blue. Why? Newer studies suggest red cones recover faster, so leftover red signals mixed with blue creates a purple after image. This just shows how much we still don't fully understand about vision. Scientists have debated on after images for years with conflicting theories and results. It's a fascinating reminder of how complex and amazing our eyes and brains really are. Now, on to the next question. How long do after images last? When you stare at a bright image for longer, we now know our cone cells get more tired, and hence they need extra time to recover. That's why, as our results showed, the longer you stare at a bright image, the longer the after image lasts. Have you also noticed that as you move your eyes, the after image moves too? It's like they are painted on your retina, where they are stuck to the exact spot that was overstimulated. I also found that constantly shifting your eyes causes after images to fade more quickly. Why? Our brain assumes that the world around us is stable, so if something constantly moves along with your eyes, it labels it as unimportant, like filtering out unnecessary noise. That's why I also told participants to focus on a specific spot of the bright image. But some participants couldn't resist letting their eyes wander all over, and guess what? No after images observed on their first try. So, the next time you spot something that isn't really there, just remember, it could be your brain's clever way of showing off the complexity of your vision. Thank you, and I hope this video piqued your interest in after images.